Today I'll be doing LeetCode Biweekly Contest 29. It's greater than, okay. What if it's not? Oh, okay, they're unique. So, just need to find the minimum and the maximum. And also the sum. And then turn something divided by double salary plus size subtract by 2, the min and the max. And sum minus min minus max. Run code. Just need to factor it, yeah. If k, first I subtract from k. If k is too big, then return is 1. Else I return v of k. I go through, try to find the factors. Use example, run code. 2,500. Think these match. Containing only ones. I guess I can try with some DP. Accepted. Basically be a number of DP1 and answer so DP0 of I plus 1 is equal to if it's 1, then we add 1. Otherwise, we start at 0. dp2 I plus 1, initialize it at dp0 of I. And then it's actually the maximum of, wait, actually, okay. And then if it's a 1, then we can take the max. And we take the max for the answer as well. Use examples, run code. One semester you can take at most K courses. This one is not correct. Okay, dp10 is equal to negative infinity. Then it should 35240. Then it should work. As for this, n is small, so think we can do some DP on bitmask. Okay, vector int minimum number of semesters to get a certain mask. The answer is just DP of the entire mask. Start from I equals to 1. Accepted, okay. And then create a vector called prerequisites. So I'll go through each dependency, and then if prerequisites of a1 minus 1, the prerequisites will be a bit mask. Okay. So we basically try to transition from somewhere. Okay, so now we find the ones where you can transition, the courses which you can take. So if I is a super mask, so if prerequisites J that means J works. Okay. And then we need to calculate a new mask. Yeah, I should set everything, should initialize everything with to infinity. So starts at this, and then I'll try to transition. Then I XOR, I add this to the bit mask, v of k. Yeah, okay. And then L is the new mask, so dpi where L is equal to minimum of dpi where L and dpi plus 1. We only do this if okay, so if built in pop count j is greater than k, then we just continue. Example test cases and run code. 3, 4, 6. 3, 4, 6, submit. Let's hope that I'm fast enough. 8 minutes. Time limit exceeded. 15. How did that happen? Oh, wait, okay, I added new things. Oh, okay, so okay, now it's accepted. I forgot to add this part. Yeah, so basically I need to add, so I need to make sure that like I did not add this class before, because if I already added a class before, then if I consider classes I already added before, then this loop here, this is 2 to the n, and this is another 2 to the n, which makes the entire algorithm 4 to the n. But instead, if we only loop through bit masks which are not in I, then it's 3 to the n instead, which will work for n less than or equal to 15. So I think because of this, I will not get first, which is a bit sad. Oh, wait. I am the first to like finish question 4, but my finish time is absolutely terrible because of the 5-minute penalty. So then like I can very much expect someone to beat me easily. I think I was fast enough for the first 3 problems. But then, because of this incorrect attempt, yeah, that really sucks. I'm surprised nobody solved question 4 yet. Like, you mean it looked like a hard problem before I saw the constraint that n is less than or equal to 15. But anyways, guess I'll explain the problems a bit because I have nothing to do. So first problem, you just need like you want to exclude the minimum and maximum. So when calculating the average is the sum divided by the number of elements. So the sum, you calculate the total sum, subtract minimum and maximum, and then you subtract 2 from the number of elements because you need to exclude the minimum and maximum, and then you take this, that's the answer. Yeah, it's pretty simple. The k factor, you basically just check each number from 1 to n, and if it's a factor, then like put it in like a vector or something, put it in a list, and then you check the size of the list to make sure it's greater than k. Make sure that k is not too big. Yeah, if k is too big, you return -1. Otherwise, you can just return the kth element in the list. This is pretty straightforward as well. See if anyone has solved this. No? I mean, it's been 12 minutes. Maybe the server is lagging. Maybe the judge is like a bit slow. Yeah, rankings may not be updated in real time, which is sad. Oh, yeah, someone beaten me. I was like 3 minutes faster, but because of the penalty. Okay, whatever. Problem 3. It's basically, you want the longest subarray of ones after. Wait. Why is this correct? Oh yeah, it should be. Anyways, so if you consider the optimal solution, basically consists of like a lot of ones and then some extra element in the middle and then a lot of other ones. So this part will be dp0. dp0 of I stores the maximum suffix, which is all ones, in the prefix of I. And yeah, that's calculated pretty simply. So if the current element is 1, then you just add 1 to the previous prefix dp. Otherwise, if it's 0, then you start at 0 again because it's the empty suffix. And then for dp of 1, you have 2 choices. For dp of 1, you could either just added this new element. So the first case is if you just added this new x. Then you just take whatever prefix was before. So if you're like, this is I plus 1, and you take whatever you take dp0 of I, like whatever value was here. Otherwise, if you're calculating the value for like, let's say over here, first you need to make sure that your current element is a 1, and after that, you basically just add 1 from the previous value of dp1. And lastly, your answer is just the maximum over all DP ones. Yeah. Oh, rank 8. Wow. I really, yeah, I should have been not, wait. Rank 5 if you exclude the LeetCode China users. But it really should have been rank 1, sadly. And for the last problem. So DP of you need to use bitmask DP. So DPI stores the minimum number of semesters you need to take all of the courses in the bitmask of I. So your answer is just DP of like the full mask. And then yeah, basically starting from each mask, you just calculate. If you want to transition from DPI first, you need to find which courses you're allowed to take within that semester. You can do this, like, just iterate through all the courses and put them in a vector. And then you iterate through all subsets of the vector. And then iterate through all subsets of the courses that you can take. And if the subset is too big, then you just ignore the subset. Otherwise, L is like, here I calculate L, which is a new subset, and then you just transition to I or L. So you basically combine the two subsets together. And then you add 1 because you need a new semester for the new subset of classes. And yeah, that's basically it. So, I mean, this wasn't a hard implementation problem, but yeah, like, people were still a bit slower than I was. And this still feels pretty sad. But anyways, hope you enjoyed and learned something from this. Goodbye.